I welcome you to this session of combinations. This session of combinations is a continuation of the sessions combination 1 4 and 1 3. So, anyone who has not watched these sessions, I suggest you go and watch these sessions first and then come back to combinations 1 5. So, in the previous session, we have seen that if n points exist in a plane, then the maximum number of lines that can be drawn is given by nc2. And similarly, if we have n lines existing in a plane, then the maximum number of points of intersection of these lines is given by again the same nc2. Now, suppose in the second case, that is when n lines are given in a plane, we were told that none of the lines were parallel. Now let us assume that n lines exist in a plane, and out of these n lines, r lines are parallel. So if r lines are parallel, these r lines cannot intersect among themselves. So for example, out of n lines, say 4 lines are parallel. So obviously these 4 lines cannot have any point of intersection among themselves. So how many point of intersection would have been there if these 4 lines were not parallel? There would have been 4 C2 points of intersection. Obviously, these 4 C2 point of intersections must be subtracted from the n C2 points of intersection, which are the maximum number of points of intersection if n lines lie on a plane. So what happens if r lines are parallel? If r lines are parallel, then total points of intersection is given by nc2, which is the maximum number of points of intersection, minus rc2, which could have been the points of intersection among these r lines. And because these r lines are parallel, these points of intersection now are not possible. So let us look at one question. What is the maximum number of points of intersection if 10 lines are drawn on a plane and 4 of these lines are parallel to each other? So, if 10 lines are drawn in a plane, what is the maximum points of intersection possible? The maximum number of points of intersection possible are 10C2. And to calculate the maximum number of points of intersection, we just ignore the second part of this question for a moment, that 4 lines are parallel. So maximum points of intersection are 10C2, which can be calculated as factorial 10 upon factorial 2 into factorial 8, which is equal to 45 lines. Now let us draw 4 parallel lines. When 4 parallel lines in this case are drawn, you can see that these 4 parallel lines will intersect with other 10 lines, but they will not have any point of intersection among themselves, and therefore the final number of points of intersection which are feasible is given by 45, which is the maximum points of intersection, minus the points of intersection which can be formed by these 4 lines among themselves, because this number 45 also includes all possible points of intersection that can be formed by these 4 lines among themselves. So minus 4C2, which is equal to 45 minus, which is equal to factorial 4 upon factorial 2 into factorial 2, which is equal to 45 minus 6, and therefore we can have a maximum of 39 points of intersection. Now let us take another case. So far we had seen the total number of points of intersection when n points lie in a plane, and that total number is NC2. Can we use this information to find out the number of diagonals in a polygon? Now, before we identify this number of diagonals in a polygon, we must understand the term diagonal. So in any given polygon, let's draw one hexagon. So if there is a hexagon A, B, C, D, E and F, if this is a hexagon, a diagonal will be a line joining two points, two vertices which are not adjacent to each other or which are not next to each other. So diagonal is a line joining two vertices which are not next to each other or which are not adjacent to each other. That means if we consider point A, then the two points which are adjacent to point A are B and F. So the line joining A and B or A and F will not be the diagonal to this hexagon. But the line joining A to C, A to D, A to E, these three lines will be diagonals of this hexagon. So how do you find out a general formula, or how do you create a general formula which will give us the number of diagonals of this particular hexagon? We again start by the total number of lines that can be drawn with 6 points. So if there are 6 points, then the total number of lines that can be drawn will be 6C2. We cannot have more lines than 6C2. And now these lines AB, BC, CD, DE, EF and FA, these lines have also been counted in 6C2. But these 6 lines which form the sides of the polygon or sides of this hexagon are not possible. So we subtract 6 from 6C2 and we will get 9 diagonals as our answer. If you simplify this, you will get 9. So you can see how we can determine the number of diagonals in a hexagon logically. Now suppose this were a heptagon. If this were a heptagon, then the number of diagonals would have been 7C2 minus the number of sides in a heptagon. So 7C2 stands for the maximum number of lines that can be drawn if 7 points lie on a plane, and minus 7 because these 7C2 lines also consider the 7 sides of the heptagon. Or if we have a pentagon, what is the maximum number of lines that can be drawn with 5 vertices? 5C2. But if you want to calculate the number of diagonals, you will have to subtract the number of sides from 5C2. So can we generalize this now? We can generalize this by saying that if there is a polygon with n sides, then the number of diagonals of the polygon is given by nc2 minus n. So let us take a look at one question. What is the number of diagonals in an octagon? So how many sides does an octagon have? An octagon has 8 sides. So n is equal to 8. So therefore, the number of diagonals in an octagon is given by 8C2 minus 8, which is equal to factorial 8 upon factorial 2 into factorial 6 minus 8, and factorial 8 upon factorial 2 into factorial 6 is reduced to 28, and 28 minus 8 will give you 20 diagonals. So with this we come to an end of this particular session. If you want to watch more videos or solve more questions, please log on to our website www.pfindia.com, or if you have any queries, please write to us at studentservices@pfindia.com, or you could also use the Ask a Doubt feature if you are watching this video on our website. Thank you very much.